Today we're going to be working with writing equations from word problems. So here's a chart you have on your paper, and we're going to put some keywords in there that mean addition, subtraction, multiplication, and division. These are things that help you know. They're not definitive, and sometimes it's really the words around them that help you know. So let's get our addition ones in. So here we have sum, which is the answer to addition problem, both, increase, together, another, all together, combined, and all. And you know, there's more that you can come up with, and so add them to it if you do. Let's do subtraction. So we have decrease, fewer than, less. Words that end in ER like higher, larger, faster, stronger, less than. And then this guy right here, difference. This is the one I really want to talk about. Each year on something, when I ask what's the difference between two numbers, someone tells me, oh, well, that one starts with an 8, and that one starts with a 3, and it has more digits and less, and, you know, that one has 5 even and 2 odds. Difference means subtraction. It's not like difference in English language arts when you're asked to describe the differences between something. You're not doing an analytical analysis. You're doing a subtraction problem. Every year someone does it. So now let's do multiply. We have of, at this rate, factor of, product of, increase by, each, per, doubled, tripled, quadrupled, etc. Every. That word of is one too. So per and of are ones you're going to see a lot of. And you remember per means for every. Percent is for every 100. Miles per gallon is how many miles you go per each gallon. So just remember those words. Those are new ones. So let's do division. Each, equal, equally, split, ratio, equal pairs, groups, separate. Those are all some kind of keywords that help you know that you're talking about division. Now I want to add something to this, and so looking at your paper, you probably have room to add just a little bit that we're going to add. Oops. On the margin here over here. We're going to put a couple of keywords for equal. On mine, I don't have the room, so I'm going to write mine at the bottom, but that's where your problem starts. So just over here on the side, write the word equal, and then we'll have some keywords for that. So we have is, are, was, were, will be, gives, yields. Those are some of those keywords that help you know that we are talking about the solve part, the equal part. All right, so here we're just going to do some quick practice together. The first one says 6 times a number is 24, and what it's asking you to do is to practice writing an equation. It nowhere says to solve. So let's look at it. We have 6. We have a keyword times. We have that is word. What does is mean? Equal. And then we have another number. So the times obviously represents multiplication. So I could write it as 6 times my number is equal to 24. You could choose to use the parentheses. You could choose to use the dot. I don't want you really using the X. We need to start dropping that out. So the sum of a number Z and 15.8 or 15 and 8 tenths is 194 and 2 tenths. So the sum means we're going to be doing addition. That's one of our keywords for that. So I have Z. Let's see if we can make that a better Z. I have Z plus 15.8 or 15 and 8 tenths is equal to 194 and 2 tenths. So really what we're practicing here is just writing the equations. So here we have a number. Well, let's use Z for that number again. Divided by 12 is, there's that word for equal, 48. So we can write it to a Z divided by 12 equals 48. But I also know I can write that as a fraction. So I can have Z over 12 equals 48. Let me make that look more like a Z. All right, let's go to the word problems. All right, the very first thing to do is we need to read the directions. Write an equation for each word problem. Let x represent the unknown. So this is why we want to be dropping that x for multiplication. It starts getting confusing when you have x times something, and it's just a mess. So let's know that they've asked us to use a certain letter. And so if we're going to be representing multiplication, we need to use either the dot or the parentheses or putting it just next to each other. So, Zed bought a $39 sweater and a jacket. The amount he spent is $156 altogether. So, we're going to let X be the jacket. And so we have 39 plus X equals $156. So I can add the dollar sign there. So if you look at it, that all together is one of those keywords that tells us it is addition. And we know that if he spent this much on one thing and this much on this thing, that is what he spent all together. So we know we would have to do an inverse operation to find that if we were solving it out. Let's read our next one. Jason lost 7 pounds. His current weight is 124 pounds. So, do we know how much Jason weighed originally? Well, no, that's our unknown. So we don't know what it was that he weighed before he lost. But what does that key word tell us when it's lost? He lost 7 pounds. His current weight is 124. So that means he's had a reduction. He has lost pounds. So we could represent this word problem as x minus 7 equals 124 pounds. Wilbur is thinking of a number. The sum of the number and, there's that linking word, 30 and 1/2 is 255 and 3/4. So there's is, we have a number there, a number here. And so what are we going to use here? X. Sum tells us we're doing addition. So x plus 30 and 1/2 equals 255 and 3/4. Now we have one more problem to do before we're going to have you try the practice work on your own. For a craft project, each student needs 3/4 yards of fabric. The fabric costs $1.50 per yard. If the teacher has 24 students, which method could be used to find out how many yards of fabric are needed for all the students? So, good problem solvers read the problem twice, so pause it and read it again. Thank you. I know you did that. Ha. All right, so let's look. Here we have 3/4 yards of fabric. That sounds like it's going to be important. The fabric costs $1.50 per yard. I'm seeing that per. If a teacher has 24 students, which method could be used to find, so we're solving something, or finding the method to solve it, how many yards of fabric are needed for all the students? So let's look at what our question is. We need to know, let's go back, how many yards of fabric? All right, so I've circled some numbers, I've underlined my question, I've rewritten my question. Now I need to go back and look at it. Do I need everything that I underlined? Well, let's see. For each craft product, each student needs 3/4 yards of fabric. Well, I know that because we need to know for all the students. So the students need how much? 3/4 each. The fabric costs $1.50 per yard. Does anywhere in my question it asks me how much does the teacher spend, or how much will the teacher need, or if she paid with a 20, how much would she get back? It doesn't in this case, and so that guy is extra information, so I don't need what I circled there. I can cross it out. So I do not need the cost on that, and the only way I'm going to know that is if I carefully read my problem. If the teacher has 24 students and they each need 3/4 of a yard, how am I going to find out how much fabric is needed? So I'm going to stop and think. I know I need the total yards needed. I know that each student needs 3/4 of a yard, and I know that there's 24 students. So, what can I do? So each student needs that. Will I multiply or will I add? Because I'm not going to be subtracting. I'm not trying to find the difference or I've used up so much. This is a addition or a multiplication problem. So those are my two key operations, because I know I have this, but I know that each student needs this. They each need this. So that tells me, since it's the word each, and they both need it, that is going to be a multiplication problem, because 3/4 is my fabric and each student needs it. And so what I'm trying to find right now is how many yards. So just even by looking at the problem before I go to the answer choices, I have figured out by my own smarticle particles that the amount of fabric needed is going to be 3/4 per each student, and I have 24 students. So let's go find which answer choice matches this. Well, this one has the cost in it, and it's a division one. This one, that one would be great if I need to know how much it costs for all 24 students. That's a great one, but that's not what I need for this one. What I need is, do I need that one? That's multiplication. Well, but that's 24 students times 3/4. That kind of looks like what I have here. Let's check the next one. This one, that is the cost times the amount of yards. So that would tell me how much they're spending on one student. So my best answer choice is this one. Now, B and D are all good representations of things you can come up with this depending on what the question is asking. In this case, the question is asking just how many yards for all the students. If I wanted to find the cost for all, this is cost for all, this is cost for one. And so you can't necessarily discount knowing why those are not ones that we need it right there, because you never know how they're going to phrase it. Oops, I put cost all again for cost for one. So what you're going to do is you have on the back side, you have a couple of going through word problems and finding the equation that matches the information. As you know, with our practice, this is where we want to be struggling, asking questions, and definitely getting it checked by the teacher before moving on to your homework. That is pretty much a mandatory thing. We want to stop the problems now. We don't want you to do all the homework wrong or miss something up. So please use your notes, use those keywords, and know that those keywords are suggestions. You can add more to it, and sometimes, depending on what's around it, it fits with other things too. So you do have to be a careful reader on these. All right, good luck, and let a teacher check it.